review from pre-cal about can you use this exponential growth model. So did they give me a constant growth rate in the problem? No, they did not. But they did tell me that we were starting with how many grams?
10.
We are starting with 10 grams. And we're going down to 1 gram, correct. So I know I need to have 10 grams, I need to have it come down to 1 gram. But if I put in a 1 here and a 10 there, do I have enough information? No, because I need to know the K value in order to solve for the T. So that's going to go right back to half-life, correct. So if you'll look down here on this chart, it tells you that plutonium-239 has a half-life of 24,360 years. And that's going to be a time value. So we want to use half-life first. Before I try to figure out how long it takes for 10 to decay away to 1, we're going to have to use half-life. So if we start with our model, half-life would mean there's how many grams remaining if we started with 10? 5. So we'll go with 5 here. You're starting with 10. Use E, and your time is 24,630 years, and now we're trying to solve for K. So you have to solve for the constant because they're not giving you that information. You have to figure that out. So when I divide by 10, of course, we get what number? That makes perfect sense.
It's 24,360.
Thank you.
Points.
He gets points.
Yeah.
Thank you. Okay, so of course when you divide by 10, we get what value? 1/2, which should make perfect sense because this is half-life. So 1/2 is e to the 24,360 K. So what am I going to do to solve for K?
We're going to do a
Yeah, ln of 1/2.
equals
24,360 K. Now use your calculators, take ln of 1/2, divide it by 24,360, and we will get a K value. I do not want you to round this K value. I want you to store it in your calculator or use the number that is already stored in your calculator. You don't have to store it, it's already stored. But we'll use that long decimal when we're computing our final answer. Do you get something in scientific notation? Yeah. Wyatt, don't forget your bonus point for fixing that number for me. Okay, so do you get negative 2.84 times 10 to the negative fifth? Now, I rounded it to write it down, but you're going to just remember, go back up and highlight that number when we get ready to use it again in our calculator. So now we can go back and say, how long, which means I'm trying to solve for T, how long does it take for the 10 grams using this same rate of decay to decay away to be 1 gram? So now you'll go with 1 and 10, e to the so this time I don't know the T value, but I do know the K value. So now remember, we're just trying to solve for T instead. So we'll go through the same process, divide by 10. Take the ln of 1/10 and divide it by that long scientific notation decimal. You get 80,922. Let's round it to 0.1 years. Is it 0.1 or did you say it's 0.2? It would be 0.2 years. Did you have a negative right here? pause that video?
I mean, you could like stop it and then restart it.
But it'll be a whole nother video.
You can cut those two. You shouldn't cut it out though, like when she's editing.
Okay, let's go to the next example. Can I get a reader, please?
Yeah,
Thanks.
4 months after it stops advertising, a manufacturing company notices that its sales have dropped from 100,000 units per month to 80,000 units per month. If the sales follow an exceptional pattern of decline, what will they be after another 2 months?
You mean exponential?
Well, it would be exceptional in a bad way, but it's
Not
also
bad.
mathematical, exponential, so we're good. We're good. We're good. It's exceptional for their competitors, I guess. So, did they give me the rate at which this is declining?
Yes.
The rate?
No.
No. But don't I need to know that rate to be able to figure out what's gonna happen in the next, whatever, 2 months that they ask? So you're gonna have to do the same math we did before with half-life. Now we're just gonna do it with some kind of business situation instead. It's the same mathematics. So we wanna figure out what is that rate that it's taking for it to decay from 100,000 units to 80,000 units. So aren't we starting out with 100,000?
Mm-hmm.
We want to find out when is it going to equal 80,000. E to the, what was the time there?
2 months.
4 months after it stopped advertising. So we're gonna let T be measured in months. So that would be 4K, and we're trying to find out what that K value is. So you know the math, we just did it. Yes, sir.
Is this the one where you use months or do you have to convert it to a percentage of years, like decimal value of years?
Since the question is written, this information is given to me in months, and it's asking me to calculate after another 2 months, I'm just gonna use this in months. So when we communicate what our rate would be, it would be that rate per month, instead of saying that would be the rate per year, okay? So since the problem's consistently in months, I'm just gonna leave it in months. If it mixed the 2 units, we'd have to choose one to use, years or months, but it is okay to use it in months. Just like up here, Isaac, it would be okay to calculate half-life in days if needed. So you does not have to always be in years. You can use a different unit. Okay, so have you found the K value?
Oh, whoops, I was listening.
Divide by 100,000, don't you get 0.8?
Mm-hmm.
Equals E to the 4K. Take ln of 0.8, divided by 4, and you'll get your K value. A long decimal. Negative 0.05579. But we want to be careful to use that entire decimal when we start calculating now what's going to happen in 2 months. So if I started out with 100,000, how many months did it take for it to reduce down to 80,000?
4.
4 months, and now we want to know what happens 2 months from then.
So 6 months.
So, no, I'm still going to start with my original 100,000, but what would I use for my time?
6 months.
6 months. So use time equals 6 months. So your formula really is 100,000 e to the negative 0.05579t, and now the t value that you're going to use would be 6. So now find y of 6. If we're talking about units, I'd be just round it to a whole number. We're not going to sell a decimal of a unit. $71,554
54.
units.
Mm-hmm.
You good? You coming back to you? Remember doing this now in pre-cal?
7155.
Okay, so the same math model applies to radioactive decay, it applies to declining sales, it can also apply to population growth. So let's see how this model applies to this situation. Could I have a reader, please? Thank you.
Not me.
Yes, sir.
Suppose an experimental population of fruit flies increases according to the law of exponential growth. There were 100 flies after the second day of the experiment and 300 flies after the fourth day. Approximately how many flies were in the original population?
Okay, so we need to find a K value, don't we? But do I know the initial amount? No, I really don't. But for this same population of fruit flies, shouldn't the K value be the same throughout the population? So for now, all I have is this information about there were 100 flies after the second day and 300 flies after the fourth day. Could I bump this back 2 days? Just so I could calculate the K value? So to find K, I'm going to use time is 0, and I'm just going to say we actually started with 100 fruit flies. So I'm now to find the K value starting on day 2, but keeping in mind 100 is not really our initial value. So I'm only using this information to find a K value. And then I would use T is how many days go past when the population changes from 100 to 300? 2 days, because it didn't really go from day 2 to day 4. So I'm bumping this whole thing back 2 days just to calculate the K value. So for right now, I'm going to use time is 0 and I have 100 flies. And time is 2, I have 300 flies, only to calculate the K value. Am I going to use 100 as my initial amount? No, I'm not. I'm going to use 100 in my initial amount. So let's see about when does 100 turn into 300 if we're using 2 as our time. So that would give us 3 is e to the 2k. So isn't your constant whatever ln of 3 divided by 2 is? Like 0.54930 blah blah blah. So I have found my K value. Now I can go back and start writing out what my exponential growth model would be. Y equals CE to the 0.549t. And now to go back and calculate this value of C, I can use either one of my original pieces of information. Originally the problem says that on day 2, you have 100 flies. Or it says on day 4, I have 300 flies. So you can use either one of those data points now to substitute into your function to find C, the true C value. So I'm going to just go with the 2 and the 100 because that's a little simpler. So 100 equals C e to the 0.549 times 2. So you're going to divide by whatever that e to the 0.549 times 2 is. So how many fruit flies were there initially?
Like 33.
33. And we don't use a decimal value for that because you have to start out with a whole number of fruit flies, right?
Mm-hmm.
We could chop one up.
We could. But then you can't